Lesson 7-1, Multiplying Monomials. Our essential question today is how do you determine if an expression is a monomial? Our first new vocabulary word is the word constant. The word constant means something that does not change. So an example of a constant in math class would be a number, like the number 3 or the number -5, a number that you know the value of, so it doesn't change. A monomial, the prefix mono means one, so a monomial means one term. On our next slide, we'll see some very specific rules for monomials. Now we have three different properties. We have the product of powers, the power of a power, and the power of a product. And these three properties for exponents individually look like they might be kind of simple, but when you put them all together, they get kind of complicated. So the product of powers, the word product means multiply, and powers, you can think about powers as being an expression with a base and an exponent. So the product of powers would be something like this. X to the power of A, that's a power, and then times x to the power of B. So the product, because I'm multiplying together, two powers. So what happens is there's a shortcut that says as long as your base numbers are the same. So with a power, I'm going to write this over here, with a power like this, we call the x the base, and then we call this a, this little raised number, the exponent. So that whole thing is called a power. So now what we're doing here is we're multiplying together two powers. So if they have the same base, and they're being multiplied together, you can add the exponents. And you write the base only once. I'll be explaining why this is true on one of our later slides. So this is the product of powers, the product of powers. You move this down a little bit to give me some more space. Now, power of a power. A power, so here's a power, and if we have a power on a power, like this, that means that you would multiply your exponents together. So, multiply the exponents instead of adding them. And our third property says power of a product. So that means that you've got two things multiplied together. So you've got a product, and then you have a power on that product. So what happens with this is you distribute and multiply your exponents. So this would be x to the power of A and y to the power of A. So you distribute that power to everything in the parentheses. So very tricky. Distribute the exponent. All right. So a constant is something that does not change. Like, for example, the number 3. A monomial means one term, just one term. And then product of powers means that if you're multiplying together two powers that have the same base, you can add their exponents. Power of a power means you have an exponent outside of parentheses and an exponent inside. If that happens, you multiply together your exponents. And then power of a product means that you have a power outside of parentheses on a product of things that are multiplied together. In that situation, you distribute your exponent to everything inside. And if there was an exponent on your x or on your y or on your term anywhere, you would multiply it using the power of a power. All right, so our next slide has a question: how do you determine if a term is a monomial? So a monomial, in the definition, mono means one. So monomial is one term, one term. So we've got a lot of terms over here. It's a click and drag, and I'm going to drag over the ones that are monomials. Negative 530, that's just a constant number. That's a monomial. F to the 4th G, that's a monomial. A monomial is a product. It's let's see, it could be a constant number, or it can be numbers and variables multiplied together. Multiplied together. So the product of a number and one or more variables. What else is a constant? 3/4 is a constant, so those are both constants. 10xyz is a product of a constant number and variables. So that would be good. And that's it. Those are the only monomials that we've got here. So a monomial is a constant or, so a constant number or a product of a constant and one or more variables. So these other ones are not monomials. This is not a product of variables. This is being divided. So you can't have a variable on the bottom of your fraction. So you cannot divide by a variable in a monomial. Product means multiply. So here's another one that would be dividing by a variable. Here's another one, because it has a negative exponent, that is actually the same as 1 over j to the 3rd. So the negative exponent actually represents a fraction with a variable on the bottom. And then these others, this one and this one, these are binomials. They have two terms. They don't have one term. They're binomials. They have two terms that are separated. If you see a plus or a minus in between terms, those are different terms. Negative x plus 5. That's two separate terms. And then this bottom one, this is a trinomial. It has 3 terms. So it's not a monomial. A monomial, so it can have a number and it can have letters, and those letters can have exponents on them as long as they're positive, because it's a constant number or a product of a constant and one or more variables. Product. So like this term right here means 10 times x times y times z. So it's a product of that constant 10 and one or more variables, x, y, z. This one would be 8 times f times f times f times f times g. That's how you would write it as a product. All right, now let's simplify using those 3 exponent rules that I talked about. So b to the 2nd times b to the 5th. b to the second power means b times b. B to the fifth power means b times b times b times b times b. I'm not always going to expand things, but I just wanted to show you that if you multiply these together, there are actually 7 of them. So this is b to the 7th power. So remember how I said if your base is the same, so these are the same letter, you can add together these exponents. That's your shortcut. That's what this property says. On the next one, we'll do the same thing. X to the second, x to the 7th. And then, if I bring down my multiplication between them, I can just count how many there are. And there are 10 x's. So x to the 10th power. An exponent means multiplying something by itself. So that same thing being multiplied by itself over and over. If I write in this exponent 1 and I add together those exponents, I get 10. So you don't have to write it out and expand it to get the correct answer. You just have to be able to keep all of the exponent rules straight. So you see the same base each time, you can add the exponents. Next up, negative 6n to the 3rd would look like this. 2n to the 2nd looks like this. Then because they're in parentheses next to each other, they're multiplied together. Well, I can change the order. The commutative property says I can change the order of what I'm multiplying. So I can change it like this. And then negative 6 times 2 is negative 12. And I count that I have 5 n's, so n to the 5th power, like that. So the coefficient, the constant numbers, get multiplied together. The constants, and then you add the exponents. So I multiplied together the constants, I added the exponents on the ends to get the final answer. On this one, I'll just do that as a shortcut. I can put a 1 in front here, so that I can multiply together. 3 times 1 is 3. And I can add my exponents. This p would have a 1 on it, and this p has a 4, so that would be p to the 5th power. And then my x's have a 3 and then a 2, so x to the 5th power. This one had 2 different letters, 2 different variables, so I couldn't combine it all together. So if you have 2 different variables or 3 different variables, just be careful. Make sure that you are identifying the exponent on each one. And you might have to write a 1 in like this on the p where I wrote in the 1. Okay, another one like that. So in case you want to see this one expanded, I'll expand it. So 3xy to the 4th looks like that. Negative 7xy. And on this one, negative 1x squared y to the 3rd. If I regroup it, commutative property, I can multiply 3 times negative 7 times negative 1, and that would give me a positive 21. And then I have an x and 2 more x's, 3 more x's, so I've got 1, 2, 3, 4 x's, so x to the 4th. And then y's 1, 2, 3, 4. 1 here, and then 3 here. Okay, so that gives me a total of 8. Like that. You don't have to expand it. Again, you can multiply 3 times negative 7 times negative 1 and get the 21. You could put a 1 here, a 1 here, a 1 here, and then add your exponents on your x's and add your exponents on your y's. And you could get the correct answer that way. All right, now we have this exponent on the outside, So what that means is that we are actually multiplying 4yz squared by itself 3 times. So 4yz squared, like this, 3 of them are getting multiplied together. Now, 4 times 4, I'm not going to expand all of this. 4 times 4 is 16, times 4 is 64. And then if I add my exponents on my y's, I get y to the third, and I add them on my z's, I get z to the sixth, like that. This next one, 2, my exponent on the outside is 2. If I want to use the shortcut here, I could distribute this 2. So that's what I talked about at the beginning, distributing to everything inside. Here's what that would look like. Negative 2 squared, y to the 6th power, and z to the 4th power. You have to remember to multiply when you distribute, multiply the exponents on that shortcut. You could always expand this if you wanted to. Now, negative 2 squared, negative 2 times negative 2 is positive 4. So there's my final answer. 4y to the 6th, z to the 4th. Up here, I could have distributed my exponent, 4 to the 3rd power, y to the 3rd power, and then z to the 6th power. Multiplying the exponent times the one that was already there. And then 4 to the 3rd power is 64. So 64, y to the 3rd, z to the 6th. So you can use the shortcut and distribute your exponent. Just be careful and make sure that you are distributing to everything in the parentheses. Everything, the constant number and each variable individually. Okay, more complicated again. Well, when you have a power on a power, this power on a power right here, you can multiply together. So then we really have 5r to the 3rd x, and 2 times 2 is 4. So you can multiply those together because they were both outside of the parentheses. So multiply them. Then you can distribute to everything inside. So 5 to the 4th, r to the 12th, x to the 4th. 5 to the 4th, 5 times 5 is 25, times 5 is 125, times 5 again is 625. So r to the 12th, x to the 4th. And that is our last example. So you should be able to write a summary now, answering your essential question. Make sure you use complete sentences and restate the essential question.